All right, so let's get started. Good afternoon, everyone. My name is Philipp Langer. I'm working with EclipseSource, and I'm really excited that so many people joined this talk on building web-based diagram editors, which is actually a topic that that is becoming more and more important to us in the recent years. In particular, I would like to focus in this talk on basically the idea, taking the idea or the architectural pattern of language servers, or the language server protocol, and apply it to graphical languages in order to allow for web-based diagram editors. But before I get started into the talking about this rather recent project that we have only started a couple of months ago, I mean, we've been thinking about it for quite a long time, but only had the opportunity to start it very recently. I would like to talk a little bit about our journey that we took to finally end up here, because I think it's important, since this significantly shaped the requirements that we actually have for this graphical language server idea. So, as many of you might know, at EclipseSource, a large part of our process, of our projects are dealing with building domain-specific modeling languages for various domains. And since these are domain-specific, and therefore have to take into account the different backgrounds, application domains, and toolings that these domain experts use. Obviously, also these modeling tools look quite different. So, depending on what the preferred way of interacting with a model for a domain expert, we might have user interfaces or modeling editors which are more form-based or table-based, sometimes text-based, and definitely also quite a lot of graphical diagram editors that we are dealing with. What all these, even though they look quite different and have a different user interaction model, what they all have in common basically is that they can be built pretty efficiently based on the tools that are available in the Eclipse ecosystem, that they are all built on the same Eclipse modeling framework, and that they are very well integrated into the Eclipse Rich Client platform. And this is actually amazing and a key factor for success, because this allows us to take all of these different ways of interacting with a model and combine them arbitrarily, provide each domain expert the preferred way of interacting with a model, and integrating that into a whole workflow so that everyone can work in their preferred way on their parts of the overall system model. So that's really a huge deal. However, this Eclipse Rich Client platform below here is, if you want to call it like that, something like a golden cage, if you know what I mean. So basically, it's a super enabler. It enables a lot of things, building integrated tools. But if you also want to cater for domain experts that are outside of this golden cage, that are, for instance, mostly using web applications or other applications, it quickly becomes very difficult to also include them in the modeling process. And this more and more becomes a problem, because there is a tendency that more and more people join the modeling process in some way or another, which is a great thing, because more and more people can contribute to an overall model. So what we actually then started doing based on this problem is that we, for instance, there was one reason why we started JSON Forms, which more or less covers this right-hand part here, to also allow form-based model editing in the web, on a web technology stack, which can then be easily integrated in all sorts of applications. Here for the textual part, thanks to Xtext and the language server protocol, this is also quite good, quite well covered. But for the diagram languages on the your left-hand side, this is rather a dark spot, or a not so well covered spot in this regard. So there is no real framework that we can just use as is to address this need. However, that's actually a pity, because web-based diagram editors would enable so many things. So one of the main benefits that we see is the deployment and integration benefit. So since all that you actually need is a browser to run those editors, you can integrate those diagram editors virtually anywhere, and really, in terms of micro injections, use modeling at the right places in the right workflows in web applications, and only provide the modeling editors where they are really needed. And this kind of also solves a problem that we from time to time see with Eclipse-based modeling tools, because it removes the smell of an IDE as soon as you put a full-fledged Eclipse modeling tool there. It sort of is sort of an IDE-like application, right? And eventually this allows us to include more people in the modeling process, and that's really an opportunity I see here. Of course, there is also another huge advantage, and that's modern UI technology. So HTML5, SVG, CSS3, these are all technologies where there is a lot of drive and a lot of innovation going on, and so they really make it much easier to provide modern-looking diagrams, have very flexible diagram styling, and also things like visual feedback and animations are way easier to integrate than, for instance, with GEF3. However, there is one big problem or one big disadvantage. That's the golden cage that I was talking about before, and that's what about the frameworks? Well, in the recent years, whenever we had the requirement to work on such web-based diagram editors, what we've been using was Joint.js, which is an open source framework for SVG-based diagrams, and it's based on Java. It's built with JavaScript, so it can be easily integrated in any web applications. It has a couple of pros. Basically, it has a decently implemented MVC architecture, so it's nice. What's really cool about this framework is it has out-of-the-box great editing support. So the way how you create models is really nicely implemented, and it provides a lot of features, a rich shape library, edge routing strategies that you can choose from, and if you happen to have to implement something yourself, there is also a nice 2D function library. However, there is two main problems that kind of kept us from getting excited about this project, and that's first of all, it's not really it is an open source framework, but it's not really a community-driven open source framework. So there is only one company behind it, and the development is not done in the open. So it's rather hard to see where things are going, and maybe also to contribute in the future if you need to. And the larger problem, so this is more a strategic problem, the technical problem is that everything is really only on the client. And why this is a problem for us, so why we need some sort of client-server architecture in our use cases is because for us, or in most of our use cases, one model does not equal one diagram. So what we typically have is that there is a larger entire model, and then there is a couple of diagram editors or diagrams or forms or whatever way of interaction you have with the model that only covers a part of this entire model. Obviously, we can't load the entire model into a browser. It might be too big, and definitely not something that you want to wait for when you just open one diagram. But this is really a problem because for many things in diagram editing, you need the understanding of the whole model. So for instance, if you want to provide user feedbacks before or after editing operation, they might depend on elements that are not visible in the current diagram. Or if you have two diagrams open and you change something in one diagram, for instance this little node here, then of course you need to update the other diagram. So you need to sort of have this understanding of the whole model. Same is true for validation and stuff like that. So that's one really important reason why we need this client-server architecture. The second one is that we would like to encapsulate the modeling language smart, so the know-how, the deep understanding of the modeling language on a Java-based component. And there is usually two reasons. Either you already have it implemented in Java, so you don't want to re-implement it again in a browser compatible language like JavaScript, or you want to reuse all these different frameworks that exist, for instance the Eclipse modeling framework, so you don't want to reinvent that just to be able to interact nicely with a browser. Also, there might be on a continuous integration server validation running and so on, so you would have to have it on the server side anyway. So that's these are the two main problems that we had when you only have a client-side editing. Essentially, when you look at that, that's really the same problem that that we have with programming languages, right? So if you open one class file in Java, it depends on other files that are not shown in the current editor, but still you need the knowledge about that. And this problem for text files has actually already been addressed with the language server protocol, right? So this is where kind of the idea came to us, where we said, okay, we don't need to reinvent everything, we just need to reapply the same pattern. So what we really need to do is to make sure that the whole knowledge and the management of the model is on the server, and only the diagrams are rendered on the client. So this brings me to another project that we have been starting to use quite recently, and that's Eclipse Prada. So I'm not sure if you have been at the talk like, I don't know, 20 minutes ago, which was introducing Sprotty. Probably a lot of you have been, so therefore I won't go into too much detail about it. So it's a recent Eclipse incubation project, also an SVG-based diagram framework, and it has several advantages over Join.js. So first advantage, at least for me, is that it's based on TypeScript, and since I'm a strong believer in a good type system, so that's at least for me a good advantage. But there are many undoubted advantages, like it has really a great and extensible architecture. So for instance, it uses dependency injection to be configured, so it's very easy to change things or extend things. It has very slim abstractions, so you don't need to understand like a deep hierarchy of layers to change things. And far and foremost, it's truly open source, right? So the development happens in the open. The core Sprotty team is open to contributions. I think it took Miro to 24 hours to react to a contribution that we sent, so that's really awesome. And it recently became an Eclipse project, which means also the IP part is taken care of. And what's really cool about Sprotty is that it already comes with an integration with Xtext, or rather the language server protocol implementation of Xtext, which is actually a really great deal for us. And the reason it is a great deal for us is because when you have Sprotty being integrated with the language server protocol, you already have some sort of client server architecture addressing the problem that we mentioned earlier. So how this is implemented in Sprotty is that there is a language server extension. So basically it is attached to a language server in order to provide visualizations of models owned by the language server. And basically this extension can then communicate with a Sprotty client, tunnels through the LSP or through the language server connection, and introduces a couple of additional action messages that the server and the client can exchange. So for instance, request the model, update the models, compute bounds and stuff like that. So basically navigation and visualization is all covered already by this protocol. So that's great. And what's also great is, of course, the server manages the whole model, has the own responsibility on the server side. The client doesn't need to know the entire model, and the protocol is really only front-end oriented. So it only captures parts that are relevant to fuel this client. It doesn't try to reach further than that, which is great. So looking at that. So what's missing? The full view as one part. Anyway, I can always open a sorry about that. So what's missing? Basically, there is already a lot that we can reuse for our goals. However, there is a few things that are missing. So first of all, as we've seen here in this picture, Sprotty currently provides sort of an extension to the language server. So the model is actually owned by the language server, sort of. And this is actually a little bit contradicting to what we mentioned, if you remember the second slide that I showed. What we really would like to have is that there is a model on the server, and then there is a couple of standalone model servers focused on providing the fueling particular representations for interacting with this model. So for instance, there might be a JSON form server which provides access to parts of this model using a form-based UI. There might be a graphical part for a diagram, and there might be or might not be a textual representation alongside of it. So we really sort of would like to have this as a standalone component. And second of all, what is missing is currently it's really focused on viewing and navigation of diagrams, which is already great, but what we would like to have there in addition is editing capability, so that the user really can edit the diagram just as you know it from existing diagram editors. So that's exactly what we've been working on in the last few months, basically starting this project. It's called Graphical LSP Framework, and the goal is really applying the architectural pattern of the language server protocol to graphical modeling. It's here on GitHub, you can check it out there. It heavily reuses Sprotty wherever it can. So for instance, the client implementation obviously reuses more or less large parts of Sprotty. And also the existing client-server protocol that Sprotty provides is basically used as a base protocol for arranging the parts, like transferring the model down to the client, updating it and stuff like that. So what we are putting on top of that is three things. First of all, the Java-based server framework to provide a framework to create standalone server implementations that are independent of a language server protocol, of a language server for textual programming languages, for instance. We extended Sprotty's base protocol with additional messages or message types to allow for editing. So for instance, like create a node, delete an element and stuff like that. And of course, we had to extend the client framework in some ways that we, for instance, first of all, are able to connect to this standalone server in terms of a client-side proxy object that allows for communicating with this server. And of course, there is some UI necessary to actually initiate the creation of a node, allow users to delete something, and so on and so forth. So this also has to be done in the UI and hooked up with the protocol, of course. So these are the three things, and I will briefly talk about each of those just a little bit before I then go to a demo. So first of all, the server framework. So it's really a framework in the sense that it can be used to build specific diagram servers. And the idea behind that is that we make generic whatever can be reused across all possible diagram servers, and provide the necessary extension points for implementing those diagram-specific parts. So what it offers is a server infrastructure which handles all this JSON RPC communication stuff, which also manages the client and the model state, and of course provides a small infrastructure for implementing model manipulation stuff. And second of all, it provides a dependency injection-based configuration module where implementers of specific diagram servers can then use this to define which actions they also want to reuse from the existing actions. They can add optionally custom actions on top of that, and they can register action handlers that they want to put in place to take care of processing actually those actions. Of course, there is a couple of generic actions that can just be reused, but of course you might need specific ones as well. And how you can think of it, how it works, I'm not sure if you can all read that, but I guess it's also fine if I just go through it quickly. So when there is a client sending a message that a node has to be created, so what this server actually then does, it deserializes the received command so that based on an API the message can actually be represented. Then this goes through the client and model management layer. So based on a client ID that the client sends along this command, the correct model state is retrieved and put in place. And then this whole thing is handed over to an action dispatcher, which looks up the action type and the registered action handlers, and then calls this action handler, which can then process the model in some way. And once the model has been processed, this goes all back the way down, so basically transferring the updated model back to the client. And as an example, I showed here create task handler. So basically think of, you have a modeling language where you have some nodes, and some of them are automatic tasks and manual tasks, so you have some sort of capability to create a task. So when the client sends a create task node message, all that actually is necessary based on this framework to be implemented is what should actually be created when such a message comes. So all this method implementation has to do is basically to create a new task node, which is sort of the view model element, set maybe a name, and if a position has been specified by this request, set the position and return it, and the rest is basically then done by the framework. You also get an index of the whole view model provided if you want to look up other stuff and so on. And you can also override other methods if you need more information to actually handle this request. Right, so we have now looked at the framework for providing a server. let's have a look at the protocol and how we extended it. So as I said before, basically all the action messages for transferring, updating, and navigating the model, they already exist in Sprotty, right? So that's no reason to implement that, so we just reuse that as a base protocol. That's very important. For all the other stuff, we have basically tried to follow two main goals. So the first goal is we would like to encapsulate the knowledge about the diagram language as much as possible on the server side, so that the client does not really need to know a lot about the diagram, or in the best case, nothing. And we obviously want to minimize client-server round trips, especially on UI interactions. So we want to avoid that you have to wait for a server round trip when you actually initiate an action. So that's the two main goals. So based on those two goals, we've added a couple of extensions for editing support. So for instance, first of all, a way from the server to the client to communicate which operations are actually possible in the current situation. So for instance, can you create this node, or can you create this connection, and so on. Remember, we wanted to encapsulate the language knowledge on the server as much as possible. Then we, of course, need action messages for the client to communicate to the server to actually run a specific action. And then there is a couple of other things like graphical move and resize, as well as drag and drop hints, which I will explain in a second. And finally, we added a couple of additional things, like an execute server action. So for instance, if you want to validate a specific element that runs, of course, on the server, but the client needs to invoke that, and problem marker support, which is also something that we would like to support. Right, so how does that look like when putting that into practice, more or less? So if there's a user starting the client, then all that happens is just Sprotty at work, basically using the base protocol for obtaining the model and computing the bounds and stuff like that. And now what our graphical language server client puts on top of that is, just remove the mouse, it first of all requests the available operations that can be actually currently applied, and the server returns a list of operations that are available. And an operation is basically just a description with an ID, a label, an operation kind. Operation kinds is, for instance, create node, create connection, or create edge, delete, move, and generic. The reason why the client needs to know that, because there are different tools or user interactions depending on which type of element it is. For instance, when you create a connection, you need to select the source and the target, and that's different from, for instance, just creating a node. So that's why we need to know that. And then there is an element type element that the operation also captures. So that is sent back to the server, to the client. The client renders a palette that provides the user the ways to really invoke those operations. And then when the user actually invokes one, we send an execute create node operation, for instance, to the server. The server manipulates the model and sends the update back to the result, basically back to the client, which then now renders the diagram update. And the same can be done for connections. However, I mentioned before that we really want to avoid server round trips. So for instance, when you now think of when you, for instance, want to move an element, it really depends on the language whether you can move one element into another. So for instance, if you have here a package and you start dragging it, you can move the package into another package, becoming then a sub-package, but you can't do that for a class. And what we really want to avoid is that the client has to know that, so has to be specialized for knowing that. But we also, so the server needs to define which moves are possible. But at the same time, we want to avoid that whenever the user starts dragging across the diagram, that we send messages from the client to the server over and over again, which produces a lot of traffic. So we would like to put in place descriptive or descriptions that give the clients hints on what is currently possible and what is not possible, so that the user, so that the client can handle that on its own. So how that works is basically we have, for instance, a request move hints operation, where the client requests those, and the server sends drag and drop hints back. And drag and drop hints in the easiest form are basically a source class and a couple of target classes, which to which this source class can be moved into. That's the simplest way of putting it. You can also do it ID for ID, but of course that produces a lot of overhead. But this type-based system is what I would say 90% of the cases would cover. When the client then receives those and the user initiates a move, the client can now interpret this, drag and drop hints and, for instance, directly give feedback to the user and decline the move. When the move hints don't contradict this move, then of course we can send an execute move operation so that the user actually moved the element. Of course, we might not be able to cover all the cases, so there might still be forbidden operations that the client would be able to apply, to perform. So for this, we have now two options to cover that with the protocol. The first one is when the client says, okay, I don't have any contradicting information that this move is forbidden, sends this execute move operation to the server, and the server identifies a violation, it can always let the operation run through or don't run through, don't let it run through, but add problem markers. So that's why we also wanted to introduce the problem markers from the beginning. Of course, from the usability point of view, that might not be everything always what you want, but at least it's a way to sneak out of a wrong operation. The second way is to reject the operation from the beginning, and I will demo that in a second. So if there is a violation identified, the server can just reject performing the operation and more or less undo the last operation. Right, so before coming to the demo, just a few words about the client-side framework. I don't want to go too much into the details. So basically, it uses Sprotty with a couple of additional things. So we have a client-side implementation of the proxy to connect to a standalone GLSP server instance. This more or less handles just dispatching the action messages that are that needs to be dispatched to the diagram server. We added a couple of client-side extensions. So for instance, that we have some sort of palette, and I admit it's a really simple implementation of a palette for now. You will see it in a second. But we also added editing tools. So for instance, that you can add nodes, add edges, and so on. And we allow persisting diagrams, initiating the persistence of diagrams. This is also what we then integrated with Theo, for instance, that you have the dirty markers on the editor, which you will see in a second. And finally, we have a couple of editing command handlers, basically to react to those invocations of tools, and then sending and receiving the respective protocol messages to the client back and forth. Right, demo time. Finally. So first of all, let me show you actually this. So this is basically an example model that is currently already running on a language server or a diagram server, standalone diagram server, which is actually running here in this Eclipse instance. So it's a really poor man's deployment, but anyway, it should be sufficient for this purpose. The reason why I'm telling you that is because I can now just move that here, click here and say always on top. And now if I switch to this one, right, then it stays visible. And now you see, for instance, when I move this, you see exactly what's being sent between the server and the client. This is why I really made this poor man's deployment. No, just kidding. This just because I did some changes right before the demo, as always. Anyway, so I just selected an element and moved the element. If I scroll here a little bit further to the right, we see here that we first have the selection of the task 1, that's the ID of this element, and then we executed the operation move. Right, that's not so super fancy, but what we also can do is we can invoke here this palette, which is filled by the operation sent from the server to the client. And the server told the client that we can create, for instance, an automated task, decision node, and so forth. So let's just create an automated task. And as you can see here, we now sent an action message to the server, and the user could create such a node. Let's just create one more node that you can see that the element type really is taken into account when creating the model element. And finally, let's just also create a connection for instance, here a weighted edge from here to here. You can see here again, create the execute operation, create connection has been sent to the server. The server really applied the change, sent back the change to the client, and the client could render it. Of course, we can also do deletions, like here, and then we can delete elements. Of course, this is not a very fancy integration of the palette, since we just reused the Thea diagram, but we really focused on the server side and the protocol for now, but it at least should illustrate how it works. So let me just show you the implementation of a generic action. Let's just put that back here. So for instance, here the move handler is rather simple. It's basically the server implementation of this of a move action. So all you see here is that this handler is registered for the action type, for all action types move operation action with this method here. And then the only thing left to be implemented is the execute method here. And there is just a bunch of queries whether the action can actually be performed. So for instance, we retrieve all the information like which element should be moved, what is the target location. If we can't find those information, it doesn't need to be processed any further. We obtain the current model element, we check if it's movable, and if it's movable, then we set the position of the new location and return the current model. So that's basically all it does. So, and you've seen that it more or less works, or that it actually works. So what I do now is I just don't set the position on the server, which is kind of rejecting to do anything at all, right? Since I have started this, hopefully, in the debug mode, when I hit save, it will be hot replaced and is now running on the server. And as soon as I start moving now things, they will just be rejected and moved back to the place as we were. So the server is really responsible for performing the operations. This is what this demo should demonstrate, and can basically reject everything. Right, I want to do it one more time because it's so cool. That's actually, but it's actually not something that we did, which is so cool, but that's something that Sprotty just provides, as we have seen in the talk before. Since we have this virtual DOM approach and this animation support, that's just awesome to implement in that environment, so that's great. Okay, one last time, and then we go back to the slides. So what's the current state and the outlook? Of course, first of all, so far we just focused more or less on the server framework and the protocol, really because that's the things that we wanted to check if there are any boundaries that we, or roadblocks that we hit. And we only extended the client as much as possible to prove something works on the server or in the protocol. Obviously, it's just we've just started a couple of months ago working on this. We had a huge kickstart based on Sprotty, of course, but still there is so much to do, and that's what we plan to do in the next steps. Basically, we want to enhance now, so we now want to more focus on the client side, basically by enhancing the generic editing capabilities in the client. So for instance, you saw the palette is just a menu, right? So that's not something that you would usually want. Also, there is no proper visual feedback. So for instance, when you draw a connection, stuff like that. We want to improve the support for drag and drop hints, introduce the problem markers because that's only available in the protocol but not really implemented yet. And finally, also we want to integrate or provide property views. For that, we want to use JSON forms. What we already did in this direction is we integrated the Sprotty client with the selection service of Thea. So basically that we can actually really, scrolling really is difficult like that. So that we really can implement this picture so that there is just two different clients which are more or less independent but just exchange things like a selection. So when you select something here, Thea propagates the selection, so this client can react to the selection and ask its own form server for retrieving the information on the property views, for instance, and so on. Right. Here, that's the, and last but not least, that's actually one of the most important parts. So we are really, I think that's a huge opportunity here to build a cool new technology that will also open up the scope of where we can put modeling into place. So we can introduce modeling now just in a, I don't know, bug tracking system or wherever we want in any web application. But no one can really do that on its own, or his or her own. So one large part of that will be collaboration and contribution of these different changes that we did. So we definitely plan and already started to contribute the enhancements that we added to Sprotty back. So we are here in close collaboration with Typefox on that. There is also an initiative going on for a couple of months now, because this language server, diagram language server protocol is something that is rattling around the community from different angles. So there has been an initiative started to make sure that the protocol definition is something that everyone agrees on, together with Typefox and Obeo. And finally, hopefully with you, because what we really would be interested in, what are the use cases that you would think are useful that we should look at. And we invite everyone to contribute, not only in terms of code, but also in terms of use cases that you're interested in, or things that you would like to see in the future of web-based diagram modeling. And with that, I'd like to say thanks a lot, first of all. And as everyone would like to give a few hints on talks that might be interesting in this related topic. So first of all, you unfortunately already missed, if you haven't been there, the Sprotty talk that has been like half an hour ago, but make sure to catch them later. There was also a talk about strategies on whether you should and when and if and how migrate to the web-based tooling. There is also a couple of talks tomorrow and the day after tomorrow about building web IDEs, EMF and compatibility to JSON, and finally about JSON forms 2.0, as well as how to build a modeling tool based on Thea. And with that, I would also like to remind you to evaluate the session if you have liked it, if you at least found the jokes funny, whatever. Give us something between 0 and +1 if we can agree on that. No, but it's really helpful for allowing us to improve our talks. And also please feel free to add free text comments, because they are also, of course, helpful. Thanks a lot. Thank you. Any questions so far? If there are no questions, oh, there's a question. Great.
Have you used this approach for modeling or editing models which don't support persistent layout information like positions and so on?
That don't use persistent positions? Is that the question? Okay. So the question was whether we have tried this approach for diagrams which don't have a persistent positioning system, basically, right? So self-layouting types of diagrams.
Use it as an editor.
Like Zets.
Like, sorry?
Like Zets, that just auto layouts.
Okay. Yeah, no, we didn't use it, but since Sprotty has perfect support for auto layouting, I think it is just a means of finding the correct mixture of editing operations together with the auto layout support that already exists in Sprotty to actually implement something like that. So if you want to add a node, we can add it still, but then leave the layouting where actually this new node will be positioned to the auto layouting algorithm of ELK. But we haven't tried it, but I don't see any reason why it can't be done. Correct me if I'm wrong, Miro. The auto layouting seems pretty nice. We haven't tried it though, but it seems really good. Okay. Yeah, if there is no further question, then feel free to just contact us either now or at the booth or via email. The doors are open. Thank you.